Welcome to Building Microservices with .NET, the basics. Before we move on to learn about microservices, I'd like to walk you through the fictional client application that drives the requirements for the backend system that you will build, the high-level architecture of the system, and the technology stack that will be used across this course. Let's imagine a video game where the player will need to acquire a series of items to stay healthy, become stronger, and survive the multiple dangers that await him in his adventures. There will be a series of stores that will allow the player to purchase items like potions, antidotes, and even swords and shields. These items have a price, and to purchase them, the player will need to present the right amount of some sort of currency that we will just call Gil. Once the player successfully purchases an item, it then goes into his inventory bag, where it will be available for him whenever he needs it. Now, the client side of this game, the app that runs in the player's device, is already being built by our company's client team, so you don't have to worry about it. And in fact, this client app is not part of this course. Our team has been chartered with building the backend services for this game, which the client will heavily depend on to be able to store the items catalog, the player's Gil and inventory, and to enable the in-game purchase experience. Let's now look at the high-level architecture of the system. To support the client applications, the following microservices-based architecture has been designed. At the core, we have identified 4 microservices: Catalog, which owns the list of items available for purchase; Inventory, which keeps track of the quantity of items that a player owns; Identity, which manages the list of players and also acts as an identity provider; and Trading, which owns the purchase process that can grant inventory items in exchange for Gil. Each of these services have their own database that has no relationship with other databases and that are of exclusive use by the owning service. For inter-service communication, the system makes use of a message broker, which allows the services to collaborate by publishing and consuming messages asynchronously. For the clients to interact with the microservices, this architecture adds an API gateway, which provides a lot of flexibility to make changes to the services without impacting the clients, and lets the services focus on their business while delegating multiple cross-cutting concerns to the gateway. There is also a front-end portal that enables the administration of the items catalog, the players, and their inventory, and it also includes a store section where players can purchase items. Finally, there are a few infrastructure components like logging, distributed tracing, and monitoring that all microservices can interact with and that can greatly help to troubleshoot issues and make sure the whole system remains healthy. Now, there are a lot of topics to cover to implement this system, so in this course, the basics, we will focus on the most fundamental parts related to microservices collaboration. In that sense, you will implement only the catalog and inventory microservices using .NET and ASP.NET Core, and you will use MongoDB to host a NoSQL database for each service. You will initially explore how the services can communicate synchronously via REST and HTTP, but later you will stand up a RabbitMQ message broker that will allow all services to communicate asynchronously by publishing and consuming messages via the Mass Transit Distributed Application Framework. That will give you a solid understanding of how to get started with microservices and .NET and how to tackle the multiple challenges of getting the services to collaborate in a resilient way. The front-end portal is based on the React UI framework. You won't be coding this portal, but you will get access to all the source code so you can build and run it in your box and use it to see how a real and modern client can take advantage of your microservices. Also, you will run all infrastructure services like MongoDB and RabbitMQ via Docker containers, which is the best way to get things up and running in your box very quickly. At the end of this course, I will point you to the next steps so you can continue your journey by implementing the rest of the system.